Hello everyone. In this lecture, we will discuss about LCD display unit, how we will interface LCD with our LPC1768 core. LCD, as you all know, it's a display unit. So anything which we want to display, either we can use the 7-segment display unit, or if in more sophisticated way, we want to display anything, we can use LCD display. So here first we will discuss briefly about the LCD display unit. So in our kit, the available display unit is something like this. It has a configuration of 16 cross 2, that means 2 lines are there, and in each line 16 characters can be displayed. So like this, explore embedded. So in total 16 characters in one lines are possible, and there are 2 lines to display. And the pixel size, there are several variants in which we can configure our display unit in terms of its pixel configuration. Here in our program, we will use 5 cross 7. So each character will be displayed in 5 cross 7 pixel configuration. So 5 columns and 7 rows, 5 cross 7 pixel configuration. This is the pin configuration corresponding to the LCD display unit. In total, there are 16 pins. Some of the pins are for powering up the device, like the first VSS, second pin VCC, third pin is for voltage control something, and these 15 and 16 for brightness and all. So some of the pins are for powering up the device and controlling it, and there are 8 data lines. So in total, we require 8 pins for data purpose, data and command purpose. These are the data line pins: DB1, DB2, DB3, and till DB7. So these are DB0 till DB7. So these are in total 8 data lines. Now to control the device, to control the display unit, we have register select pin, read and write, whether you want to read anything which is right there on the display, or you want to write something. So for that, 5th pin is there, and the 6th pin is the enabling pin. So these 3 pins, RS pin, read write pin, and enable pins, are responsible for controlling the device. So these are called control pins. Whereas DB0 till DB7, these are called data line pins, so data bus. That is all about in brief so regarding our LCD display unit. Now we'll see what the importance of register select, read write, enable, the control pins. And here it is, the first pin is grounded. This is plus 5 volt to power up the device. This is contrast adjustment. This is also happened through voltage regulation. And these are all the control pins: register select, read write, and enable. And after these 7, 8, 9, 10, 11, 12, 13, these are all data pins, data bits. This is 15th and 16th for black light anode, and 16th one is black L light cathode, anode and cathode. Now we'll discuss about the data bus. So in total, there are 8 data lines. So at a time, we can send 8 bits to the display unit. This display unit is used for displaying alphanumeric characters, ASCII characters. So anything which we can encode using ASCII format, those all things can be very well displayed over the display unit. Because the encoding require 8 bits to encode any of the character, so that's why we require 8 data lines here. So that is the importance of the data lines, or whatever we will send. So that need to be encoded in 8 bits in its ASCII format, and that encoded 8 bits we will send over the data bus, and then the display unit would interpret it as data based on the register select field, and then display it subsequently over the display area. Now in our situation, in our experiments, we will use the 4-bit mode of operation. There are 2 ways, the 2 modes in which LCD display can be used. One is the 8-bit mode and another one is 4-bit mode. If we will use the 8-bit mode, then we need 8 data lines, and those 8 data lines should be connected to 8 pins to our core. But as we all know that there is a shortage of pins over our kit, so we always want to efficiently utilize our pins. So in this situation, we will use the 4-bit mode of operation. In 4-bit mode of operation, the data line D0 to D3 not going to be used. The subsequent data line D4, D5, D6, and D7 will be used for this purpose. So we require in total just 4 pins. Now the question arises that we have to display the 8 bits. So any character need to be encoded in its ASCII format, and that requires 8 bits. So we are using the 4-bit mode of operation. So how we will then manage using 4-bit and the data which we have to send is 8 bits. So the same 4 bits we will use, the 4 pins we will use. First, we will send the higher nibble, and over the same pins, then we will send the lower nibble. And in the display unit, there are 2 inbuilt registers. One is the data register, and another one is the command register. So if we will send data register, I mean data over the data line, we will send the data which need to be displayed further. That will find its position in the data register based on what we will signal over the RS pin. So if RS pin is 0, that means it's over whatever be there over the data line. Display unit would consider it as data. If over the RS the signal is 1, then the interpretation would be that whatever be the bits, whatever be the data over the data line, that is come out. So at that time, whatever be over the data lines, that will find its position in the command register, and further based on the enable signal, it would be interpreted and executed. Likewise, based on the enable signal, if it would be the data, in that situation, it will find its position in the data register, and subsequently it will be interpreted as to display, and well will be displayed subsequently over the display area. So that is all about the data bus. Now we will go to the register select. So register select is the control line, comes under the control line categories. So register select, as I have already discussed and disclosed, that there are two types of registers: data register and command register. Because there may be two options: either we want to control, we want to send certain commands to control the display unit. Like the command could be that we want to move our cursor, we want to position our cursor to a specific line and specific character position. That is one command. We want to clear everything. That is another sort of a command. So these are all the commands. There are several other variants of the command, which we will later on discuss. So just to give you the flavor, I discuss about these two type of scenarios, which comes under the command category. So if anything like this is there, then over the register select signal, it should be 1. So if we want our display unit to interpret whatever be over the data line as a command, then in that situation, RS signal should be 1. Otherwise, if we want our display unit to interpret whatever be there over the data lines as data itself, then over the register select, it should be 0. So if RS signal is low, then LCD interprets the 8-bit info as command. Otherwise, it would interpret as a data, and subsequently, it will whatever be over the data line will find its position depending on whatever be the RS, either in command register or in data register. So that is all about RS signal. And then the next one is read and write. There are two options possible. One is either we want to display something, so in that situation we are going to write something over the display, or whatever be there over the display we want to read it, and we want to check whether something is there over the screen or not. So if we want to write anything, in that situation, read and write signal should be 0. If we want to figure out that something is there over the display, then in that situation, we want to read it. And at that time, read write signal should be 1. And when read write signal would be 1, then what our display unit would provide as an output, it would give us this one, D7. So whatever be over the display line D7, that is also called the busy flag. If anything would be there over the display unit and it is being displayed, at that time we are judging, we are asking for reading, and we want to see whether something is there over the display unit. Then at that time, whatever be over the D7, that will also act as the busy flag. So if some data is there over the data line, that would itself act as a busy flag, and then we'll come to know that something is there over the display line, and then subsequent read operation can happen. So that is all about the read write. So if for anything we have to write, then read write should be 0. If we want to interpret or we want to judge whether something is over the display and then subsequently we want to read it, then we will look for the busy flag, and that one is the D7 flag, and at that time read and write signal should be 1. And then there is an enable signal. This enable signal is important. And why it is important? Because anything which we are writing to the data line and then subsequently to the data register and to the command register, or it being latched to the display unit and then finally executed and find its expression over the display and in executing the command line is only through the enable signal. And how does it all manifest and happen? Initially, the enable signal should be 1, and at that time, something should be there over the command line or the data line, or in the command line, in the command register or the data register. And then, after a certain gap, the signal should be low. At that time, whatever be there in the data register and the command register would be latched and interpreted and executed and find its expression over the display unit. So that is the importance of enable flag. So both in terms of when you want to execute the command or you want to display anything over the screen LCD display area, in both situations, to latch that data and command to be get interpreted and find its expression over the display area, either through the data display or through the command execution. In that situation, first the signal should go 1, it should be there for a while, and then it should go down. So when it will go down, then the latching would happen. So that is the importance of enable signal. Now the next we'll discuss about the hardware connection and the schematic corresponding to LCD display. So this is the hardware connection and the display unit. So this is all about the hardware connection. And the schematic which in our program which we'll use. So here is our LCD. Here you can see the LCD. We will operate in 4-bit mode. So that's why D7, D6, D5, and D4 are going to be used as data lines. V0 is for regulating the contrast. This is anode and cathode. This is to power up the LCD display unit, 5 volt, and this one is grounded. And then these are important. So in our kit, already these things are fixed, so we don't have to worry about powering up the device. And anode and cathode and voltage contrast, all that thing we don't have to worry too much. But what we have to configure, and for what we want to figure out the pins which we will use, so the ports and the pins. So, one is for the data line and another for the control lines. So these are the 3 control lines: register, select, read, write, and enable. The situation in which you want to always write, you don't want to read anything, you don't want to figure out what is the status of busy flag or the D7. In that situation, this P2.1 which we are using, we can directly ground it. So instead of using any explicit port and pin for connecting it, we can directly ground it, which will later on in our program will definitely do, because our interest is only in writing. We don't want to judge what is the status of busy flag. Is there anything which we can read? That thing we are not interested in right now. So in that situation, this read and write control line may go and connect to the ground signal. Then RS and enable. For these 2 signals, we require 2 pins. So here we are using port number 2, pin number 0, port number 2, pin number 2. Any pin which may act as GPIO pin, and that also we have to configure as output pin. So these 2 are output pins: P2.0, P2.1, P2.2. So all these 3 are output pins, and which we will use for controlling the LCD display. As RS, we will control if we will place signal 0 over it. That means whatever be there on the data line, that would be considered as data. If we will mention here as 1, then whatever be over the data line would be considered as command. Likewise, if we will just ground it, so always our intention is to write. And the enable is in both operation, when we want to display anything or when we want to execute any command. So in both situations, first this signal should go 1 high. It should stay high for a while and then it should go low. When it will go low, then only whatever be the data would be latched to the LCD circuit, and then LCD would interpret it, convert it into its 5x7 equivalent uh, pixel configuration and format and display it. Likewise, if it would be a command, then interpret the command and execute the command. That operation will happen once we will make enable as 1 and stay enable as 1 for a while, and then make it 0. And these are the data lines. So whatever the data or the command which we have to send, we will send using these 4 pins. So these 4 pins also need to be output bound, because OR will produce output. That output will go to these data lines. So all the pins, all the 7 pins which we are going to use, 3 control pins and 4 data pins, or the control lines need to be output bound. So all ports and pins will configure as output pins. This is one observation, and we'll follow this and configure our ports and pins as output bound. This is all about the schematic. Now we will discuss about the port connection and LCD operation. So prior to the LCD operation, we will discuss the timing diagram, that how our signals should go and stay alive over the control lines when either we want to display any data or we want to execute any command. So here this timing diagram is for displaying the data. So in this situation, what should be the RS? Because it is the data, so RS should be 0. So this is the RS signal. So here at the starting until the end, it should be 0. Because RS signal allows LCD display to interpret that whatever be there over the data line is data that need to be displayed. And the second thing, when it is 0, at that time itself, your read and write signal, because we are writing the data over the display area, so read write also need to be 0. That's why it is 0. Then, as I have already mentioned, then after certain time, your enable signal should go on, and when your enable signal is going on, at that time there must be a data over the data line. Or if it is a command execution, so there must be command bits over the data lines, and then RS should be 1 at that time if it is a command. But here in this case, so it is the data which we need to display over the LCD. Then RS should be 0, read write should be 0. Then after a while, enable should be 1, and it stay 1 for a while, and then it should come down. When it will come down at this time, the data must be there over the data line. Then it would be latched to the internal circuit and then will be displayed over the display line. So this is all about the timing diagram, the importance of enable and all other control signals. Now, in brief, I want to discuss about that how we will approach interfacing LCD with our code. So already we have seen the schematic that we require 7 pins, and all those 7 pins should be configured as output pins. Once we have configured those pins as output pins, so anything which we want to display over the display lines, because there are 2 lines, so we have to send the data over the data lines, and then at the same time we have to control it using RS read write and enable. So what should be the procedure? First, there must be a data over the data line. So first we will send it. Now while sending, because any character need to be displayed or encoded in 8 bits, but in parallel we can't send the 8 bits because here are only 4 data lines. So we have to send the 8 bits. So it would require to be sent. So if we have to send the 8 bits, but here at a time only 4 bits can be sent. So initially we will send the higher nibble, higher 4 bits, and then subsequently the 4 bits. So it requires 2 times to send the data, which then will find its position in the data register and subsequently will be displayed over the display unit. So when enable will go 1 for a while and then will go 0. Before that, read write should be 0 and RS register, RS signal should be set as 0 if it is a data line. And in contrast to the data being displayed, if we want to control the display unit using certain command, then in that situation, RS signal should be 1. Read write obviously need to be 0 at that time because we want to write something over the command register and then finally want to execute that thing. And then enable should go 1 and then it should be 0. And when it will go 0 at that time, the command register would be latched and find its expression through the execution of command. So that is the basic theme on which the display works. In the next lecture, I will come up with the program in which we will display something over the display unit. So we'll control the command, several commands. We will see that how we can monitor and manage and shift to right, left cursor, how we can move from one line to another line, how we can then once again move from the second line to the first line, and even in any specific line, how we can progress ahead with a cursor and go to a specific character position, because there are 16 character position, how we can start our cursor writing from a specific character position. All those commands we will see in the next lecture. So we'll see you in the next one.